What is LINQ in C#? What does it do? How do I use it? And what problems does it solve? This time I'm going to start with a very basic code example. Then we're going to go over the definition quickly. And after that, we're going to take a look at some more code examples which demonstrate the use of LINQ in C#. If you like my videos, please click the like button and subscribe. Okay, let's take a look at our first code example. The task at hand is from a list of integers. We need to find all the items that are greater than 5 and sort them in ascending order. So if you're not using LINQ, this is the way it can be done. There are probably other ways as well, but let's do this first, and then we're going to try achieving the same task, solving the same task using LINQ. And I'm going to create a new list, filtered and sorted, which is going to be used. So let's first find all the numbers that are greater than 5. So we're going to iterate over the original numbers list, and we're going to check if the number is greater than 5, and if it is, we're going to add it to our filtered and sorted at number. So now we have found all the items which are greater than 5, so we need to sort them in ascending order. So let's do that by using the sort method, which by default sorts the items in ascending order. And now let's just print the items to the screen for each. We get int number in filtered and sorted, and we get console write line number. So let's run the program and see the output. And we found 3 numbers which are greater than 5, 6, 8, and 9, and we sorted them in ascending order. So we solved the task. Now let's see how we can solve the same task using LINQ. So I'm going to delete some of the lines, and we can do list int, again filtered and sorted, equals numbers where, and then greater than 5, order by to list, and let's run the program. Do I need to do anything else? No, I don't. And again, we get the same result. We found 3 numbers, 6, 8, and 9. But we achieved this in a single line, and as you can see, this is much cleaner, much faster. Okay, so now let's go to the definition and see what LINQ is, and then we're going to get to some more complicated examples that use different datasets to run the LINQ queries. What is LINQ in C#? LINQ, or language integrated query, is a feature which allows you to query data in a very readable and concise way, similar to SQL, and LINQ can work with different data sources such as collections, arrays, databases, XML, remote databases, and many others. LINQ also comes in 2 different flavors: query syntax, which looks like SQL, and method syntax. You're more likely to use the method syntax, but the query syntax is also usable, especially when it comes to more complex queries. Now let's take a look at the 2 ways you can write LINQ queries. The first one is the LINQ query syntax, which you can see right here. And the second one is the LINQ method syntax, also known as Fluent syntax, which you can see right here. And this is the one that you are more likely to use in your applications and to see in other people's code. But this one is quite useful and probably easier for people with SQL background. Let's take a look at our program and see what it does. We have a list of integers, 823716, and our task is again to find all the numbers that are greater than 5, sort them in ascending order, and print them to the screen. And we can do this in 2 different ways, by using the LINQ query syntax and by using the LINQ method syntax. Let's first take a look at the query syntax. You can see that from num in numbers, we find all the numbers that are greater than 5. We order them in ascending order, and then we print them to the screen. and using the LINQ method syntax, again we are finding order numbers that are greater than 5. We order them in ascending order and we again print them to screen. The LINQ method syntax uses extension methods. You can see that I'm using where and order by. You can chain them, and inside each one of these methods we have the lambda expressions, which in this case select only the items which satisfy the right hand side of the expression, meaning that order numbers are greater than 5, and our order by extension method sorts the numbers in ascending order. You can use any parameter name that you want. You can use num in both extension methods, since each one of these lambda expression is independent, or you can use any parameter name that you want. And again, we print the found items to the screen. So let's run the program and see the output. And you see that we have achieved the exact same thing using the LINQ query syntax and the LINQ method syntax. We found that the numbers 6, 7, 8 are the ones greater than 5, and we ordered them in ascending order. Apart from the where and order by, there are quite a few more extension methods that you can use, such as select, group by, first to default, any, all, count, sum, take while, distinct, and quite a few others. You can take a look at the official documentation and learn more about each one of them. LINQ is very versatile. It can be used with different types of data sources. You can use it with built-in C# collections, you can use it with databases, you can use it with XML. So let's demonstrate some of these uses and see how LINQ can help you write better, cleaner, and faster code. Let's say you have an array which contains 5 integers and you want to find all the integers that are greater than 2. You can use LINQ to do that. I have an array which is called array, and I want to find all the numbers that are greater than 2, and I can use LINQ. We're using array, and then we're using the where extension method, where all the elements that are greater than 2 are going to be added to our result, and then we simply print each one of the integers that we found and saved in the array result to the screen. So let's run the program. And we found the numbers 3, 4, and 5, which are the ones that are greater than 2. And as we saw earlier, we can also use LINQ with lists. So let's show another example quickly. Let's say we have a list, string, let's call it fruits, and it's new list with several items. Let's make them apple, and we have banana, and we also have cherry. And now let's add another one. Let's make it mango, and we need to find all the fruits which start with the letter B, and we can use LINQ to do that. So let's do that. We're going to make that, let's call it list result equals, again we start with our existing list and we go where. Let's make this fruit, and fruit starts with the letter B. We want to find all the fruits that start with the letter B. Let's actually make this list as well. And we save the result to list. And again, we're going to print this to the console. So let's do that for each fruit in the list result console, write one fruit, and we're running the program, and our result is banana. So from our existing list of fruits, we are looking for the fruits which start with the letter B. If we have another fruit with B, let's say this is our magic B fruit, and We run the program again, and now we should get banana and bee fruit. So we found all the fruits which start with the letter B. Again, we're using LINQ to do that instead of looping through all the items. And you can also use LINQ with XML. Let's do that quickly. Next. Okay, let's create our XML element. XML equals XML element parse, and we're going to have root and two child elements. So let's make this child value equals 1, and we have another child element with value 2, and we need to close the root element. So let's see if it looks good. Root child value 1, child value 2. We close the root element, and now let's find the child element which has a value which is greater than 1, which should give us this element. So let's do that using LINQ. So we have our XML result equals XML. First we need to find all the child elements, and then we're using the where extension method to find the attribute value which is greater than 1, and let's make this integer. Does that look good? Yes, it does. Let's suppress this warning, which checks for null. We're going to skip this for now. And again, let's print the found elements. So for each, let's make this we have XML element. So for each XML element in our result, we're going to print the element name and the attribute. So let's do that next. And we're going to go, okay, let's make this smaller so it fits the screen. And we're going to print this value. And again, we're going to suppress the warning. So let's run the code, and you see that we have found the second element as expected. This is the element that we found. Again, we're using LINQ to find the elements which are child elements where the value is greater than 1, which is why we found the second child element with the value 2. One of the main advantages of using LINQ in C# is that it can be used with Entity Framework Core and gives you a very powerful approach for accessing and manipulating data in a database. I have compiled a list of all the advantages of using LINQ with the Entity Framework Core, and you can pause the screen and read about them. I'm just going to mention some of them quickly. The LINQ queries are strongly typed, which means that you get compile time checking of your queries. The syntax is quite easy and intuitive. You also get very efficient data retrieval, and LINQ offers cross-database support, which means that you can work with different kinds of databases. You can use PostgreSQL, you can use SQLite, you can use MySQL, SQL Server, so basically whatever you want to, and the performance is quite good. And there's also great community support. Basically, if you're using Entity Framework, then you're most likely going to be using LINQ as well. So I'm going to show you a very quick example from a small application that I coded several days ago and demonstrate how to use LINQ queries with a database. So let's do that next. First, let's take a look at my database quickly. This is a PostgreSQL database. My table is called Candle. These are my columns. I have integer, a symbol, exchange, open time, and price, and volume, and some other fields. You don't have to worry about the fields, and obviously you might not want to use integer as an ID in your real applications. So this is not the most important thing right now. So let's quickly take a look at the database and then demonstrate how we can use LINQ to query that database and find the items that we need. These are actually 1 hour candles which are saved from the Binance exchange for the BTC USDT contracts. I have many other symbols. I think maybe, I don't know, maybe 50 symbols or so. If you want to find, let's say you want to find only the BTC USDT contracts, you can use LINQ to filter them, and you can use LINQ also to find only the candles with a open price, let's say higher than 40,000, or with a certain volume, or with a certain date. So let's demonstrate that quickly in my code. Now let's take a look at my code. I'm using LINQ to find all the candles which have the BTC USDT symbol. So let's change this and make it a little bit more interesting. Let's just use several conditions. So let's put this on a separate line. So let's say I want to find the candles that have the BTC USDT symbol and the exchange is Binance. So let's see, exchange equals Binance. And what else can we do? Let's say we want to make sure that the open price is greater than 40,000. My open price is a nullable decimal. So first we need to check that the open price actually has value. So let's do that. It has value. And we can check that the open price is greater than 40,000. And again, this is how we can use LINQ to query our database. You can see this is much easier than writing our SQL queries, and obviously by using Entity Framework Core, you are taking all the advantages that it offers. You're preventing SQL injections and you're making your queries simple and fast. And this is yet another advantage of using LINQ in C#. And that is all for me for today. If you like my videos, please hit the like button, subscribe. Thank you for watching.